Hello dear viewers, I welcome you all again here for the next tutorial, that is tutorial 3. I hope that you have seen the earlier two tutorials, tutorial 1 and tutorial 2. We had solved the same problem by Kirchhoff's laws, then by using the Thevenin's theorem and also by Norton's theorem. Now superposition theorem was remaining there. So this tutorial 3 is now dedicated for the application of superposition theorem. Okay, so this is one of the problems that we had already solved with the help of some other theorems and methods. See here now, this is one of the problems. This problem or this circuit has 4 power sources. See here, this is 2 ampere current source located here, 6 ampere current source is located here, and there are 2 voltage sources, 4 volt here and 8 volt acting in this particular manner. Okay, now see, while we apply superposition theorem, we know that we have to consider one source, any one source acting at a time. That means we have to repeat the procedure for 4 times now because we have 4 sources, 1, 2, 3 and 4. Okay, so let us start with the solution. I will write here when only 2 ampere current source acts alone. Okay, so we start from here that we consider only this 2 ampere current source is acting in the circuit, and then conveniently we have to replace the other sources in a typical manner. See, we had seen in the lecture of superposition theorem that when we are considering any one source acting, then we have to replace the other sources in a particular manner. For example, if they are the ideal sources, suppose if there is any ideal source, then that is to be replaced by a simple short circuit. And if it is an ideal current source, we have to replace it with the help of open circuit. And if they are the practical sources, then we have to replace those sources with the help of their internal resistances. So see here, we now consider that only this 2 ampere source is acting initially. That means we have to replace these 3 sources in a proper manner. So here we start. This is 4 volt source, and see, this is an ideal source because in the problem they have not mentioned whether these sources have any internal resistances. So we have to replace this 4 volt source with a short circuit like this. So I will show it here. So suppose we short it in this manner. Same thing for this 8 volt source. This is also an ideal voltage source. So here also we short it. So like this. And now this is one current source here. We have to open circuit it. So it will be done in this particular manner. Okay. So here. So there is an open circuit here. So we have to replace the sources in a typical manner. Only we will show this source acting in the circuit. Now see, our problem statement is to find the current in this 4 ohm resistor. So we mark here some terminals like this A and B, because in superposition theorem we have to also calculate the magnitude as well as the directions of the currents. So let us start with the solution now. See here, this 2 ampere current will be supplied at this node. Also 2 ampere current will be taken from this particular node. Now see here, you will find that we need to have one current variable here. So suppose we assume that current here is say I. See, you can have your own current distribution. So suppose I assume that current I is flowing like this. So 2 ampere at this particular point, it is reaching here, and I ampere is reaching to the same node. So what will be the current moving ahead? It will be I plus 2. Now see here, this I plus 2 current will reach here. Will there be any current flowing in this branch? No, because there is an open circuit. So this entire current I plus 2 will be moving like this. It will move ahead in this particular branch. Now see here, this I plus 2 reaches here. Out of that, this 2 ampere current is flowing like this, because see, this is a 2 ampere current source. So current taken from this node will be 2 ampere. So what current will go down here? The current in this particular branch will be I plus 2 minus 2. That means current will be just I. And same I current will flow ahead here. This will reach to this point B. Again, there will be no current flowing in this branch. So entire current I will be moving like this, and see, it matches with our current distribution. And now see, there will be just one single loop here. See here, you have not to consider this loop because this branch is having a current source, so it is clear that it is supplying current of 2 ampere here and taking current of 2 ampere here. So here we have not to consider this as part of the circuit, okay? Or as usual, we had shown in earlier problems also that this current source we had just replaced with floating wires, 2 ampere like this. So only this particular loop will be there. So I will just mark this loop. We write the loop equation. So loop equation will be, so very fast we write it now. From this point we start. So our loop is like this point to this, down, then towards the left and to the original point. So what will be this case? It will be minus 2 times I plus 2. So minus 2 into I plus 2. Now we reach here. From this point onwards, it will be again minus 2 times I plus 2. Okay. Now we reach here. Now we come down, no component. Then here to here, it will be minus 2I. Then we reach to point B, and from point B onwards here, it will be minus 4I. So minus 4I. And then we reach to the original point. So this will be equal to 0. So we just simplify it. So minus 2I, minus 4, minus 2I, minus 4, minus 2I, minus 4I equal to 0. So it will give us minus 2, minus 2, minus 4I, minus 6I, minus 10I. So minus 10I, and the constants minus 4 is minus 8, and we take it to other side. So equal to 8. And so I must be equal to minus 8 by 10 ampere. Or we can say that it will be minus 4 by 5 ampere. Now see, we have got a negative answer for this current. In our resistance of 4 ohm, a current I is flowing. So we are interested in finding out the value of this current I. Value of I we have calculated, it is 4 by 5 ampere. But the answer is coming negative. It means that in our current distribution, we had shown the current from B to A, but actually it must be flowing from A to B. So here we say that current in 4 ohm resistor must be equal to 4 by 5 ampere, but its direction is important in superposition theorem. So direction will be from A to B. So you have to compile the results for each and every source individually. Somewhere here we will write that due to 2 ampere source, and what is our conclusion? 4 by 5 ampere, because we will need all these results at the end, and it will be from A to B. So here I will just record all the results step by step. Okay, so first job is over. Okay, now let us move to the second battery or second source. So we don't need all this now. Here I will write when only, say let us take now that this 4 volt battery acting. So 4 volt, but now it will be a voltage source. So this will be our circuit that we will use now. See what we have written, when only 4 volt voltage source is acting alone. So this will be our circuit. See here we have shown only this 4 volt source present in the circuit, whereas we have replaced the other sources in also a typical regular manner. So this was current source, so it is open now. There was one more source, 6 ampere current source, so we have opened it here. And there was other voltage source, 8 volt source, that we have shorted. So this will be our circuit. Now see here, this branch is open, so no current will flow through this entire branch. Also this branch is open, so no current will flow. So you will find that your simple circuit is like this 4 volt battery, and whatever current is given by battery, say current I, that will come here at this node. Obviously no current will flow in this path. So all this current I will move ahead like this. This current I will come here. No current will go down because this is open branch here. So this entire current I moves ahead like this. This current reaches here. Again there will be no current in this branch. So entire current I will be coming down like this. Same current I will be flowing here. This current reaches to this point, and also the same current I will move ahead towards left. So this will be the thing. So it will be a simple closed loop like this across this 4 volt source. Again, we maintain our points, say point A and point B here. And see one single loop like this, and just one equation we have to write for this. So see here, minus 2i is minus 4i, then again minus 2i is minus 6i, and here minus 4i. So it will be minus 10i plus 4. So it will be minus 10i plus 4 must be equal to 0. This will be the simplest equation for this loop. And that means 10i equal to 4. So I equal to 4 by 10. That means it will be 2 by 5 ampere. And it will be flowing from which point? See, now we have got the positive answer. And see our current distribution. Again, we are interested in finding out the current in this 4 ohm resistor. As per our distribution, it is I ampere. And value of I we have got as 2 by 5 ampere. But we are getting plus value. That means whatever direction we had shown for this I, that must be correct. Now see here, with this direction of current B to A, we have got plus answer. So what is our final conclusion? A current of 2 by 5 ampere will flow through this 4 ohm resistor, but now the direction is from B to A. So here we will write direction as B to A. Okay, and here we compile the result. Due to 4 volt source, what is our second result now? The current is how much value? What value we have got? 2 by 5 ampere, but now direction is from B to A. So second result we have obtained. And now let us move to the third source acting. Suppose we consider this 6 ampere source acting alone in the circuit. So obviously again we have to change the circuit accordingly. That we will do. Now this will be our circuit for the third source, that is 6 ampere source when it is acting alone. So here we have written when only 6 ampere current source acts alone in the circuit. Again, as our regular practice, we have opened this current source and we have shorted these two voltage sources. So only there is a presence of this 6 ampere current source. Now obviously what does it mean? This branch is supplying a current of 6 ampere at this node, and it is taking a current of 6 ampere from this node. See, this branch is open, so no current will flow across this particular branch. So you will find that this 6 ampere current, when it is reaching here, it has two closed paths. It will flow through this 2 ohm resistor down like this and through 4 ohm resistor, and some current will be distributed in this particular closed path. So it is just like having this 2 ohm and 4 ohm in series towards left, and this 2 ohm and this 2 ohm in series towards right. So we can just use the formula for the current distribution in two parallel branches. Now see, we know the formula for current distribution in parallel branches. Okay, now we are interested in finding out what would be the current flowing through this 4 ohm resistor. Means what would be the current supplied towards left, that we want. Suppose we assume that current supplied towards left is I ampere. Now same I ampere will flow like this. So what will be this value? As per the formula, this I must be equal to the total current supplied to the parallel combination, that is 6 ampere, in bracket. Now see, we want to find in this branch. So we will take the entire resistance towards right in the numerator. So 2 plus 2 is 4 will be in the numerator. And then you have to take the sum of the resistances of two branches. See here, what is total resistance towards left? It is 4 plus 2, 6. And what is total resistance towards right? It is 2 plus 2, 4. So here we have to write 6 plus 4. So what answer we will get for this now? It will be 6 into 4 is 24. And in the denominator it will be 10. So it will be 12 divided by 5 ampere. And now see, what would be the direction? See, obviously this is our point A and this is our point B. Here we have shown. And so since the direction of current is like this, so obviously the current will be flowing from A to B. So here we will write the direction as A to B. So here we compile the third result as due to 6 ampere source. What is our result now? Our result is 12 by 5 ampere, but its direction is now A to B. And now fourth source is remaining. Now this will be the circuit for the 8 volt source. Again we have open circuited the two current sources and we have short circuited the 4 volt source towards left. Now see here, you will find that again there will be no current in this particular branch and there will be just one single closed loop like this through this battery. Current will flow here because again no current will flow through this central branch. So a current will be flowing like this, B to A here, then it will come here, no flow through this and again back to the battery. So just we write that suppose current I is flowing, okay? So current I will be flowing like this, it will be same I here, again this current I will be flowing like this, then same current I will be here in this particular manner, and see our simple loop will be this closed loop. So you can start writing the loop equation. So loop equation will be minus 2I, then here again minus 2I, then this will be plus 8, then here minus 2I and minus 4I. This all will be equal to 0. So we will get 2 minus 2 is minus 4, minus 4 and minus 2 is minus 6 and minus 10I. So minus 10I plus 8 must be equal to 0. That means 10I equal to 8 and so I will be equal to 8 by 10 ampere. So it will be equal to 4 by 5 ampere. And see the direction now. Obviously, since the battery is like this, that means current must be flowing from B to A. Or otherwise, we have got a plus answer for 4 by 5. And so the direction of current as per our distribution was from B to A. So a current of 4 by 5 ampere will flow due to the 8 volt battery and its direction will be from B to A. So this fourth result also we have got, that we will write here, due to 8 volt source. What is the result? Current is 4 by 5 ampere, but its direction is from B to A. See, now we have compiled all the results and now our last job is to finally make a statement about the net current that would flow through this 4 ohm resistor when all the batteries are acting simultaneously. Suppose we assume that current is flowing from A to B. So here we can write current in 4 ohm resistor from A to B. We just assume this right now. From A to B will be. What will be that current? Just write now A to B. This is already A to B, so we will just take this value as 4 by 5. Then second value is B to A. So we have to take this value as minus 2 by 5. Because see what we are assuming, we are finding out current, what current will be flowing from A to B. Okay, so this is already from A to B, so plus 4 by 5. This second value was 2 by 5, but it was from B to A, so we have taken it as minus. Third value is already A to B, so plus 12 by 5. And fourth value is again B to A, so we have to take a negative value. So minus 4 by 5. So 10 by 5. So it is nothing but 2 ampere. And since we have got a plus answer, that means current must be flowing from A to B. The current of 2 ampere will flow from points A to B, finally in this particular resistor. Now this is one more problem that also we have solved in our earlier tutorials, okay, with the help of various theorems. Now let us solve this problem with the help of superposition theorem. Again see, look at the circuit. You will find that there are two current sources, 15 ampere acting here, sending current in this direction, and 10 ampere source acting in this branch, sending current downwards in this direction. Okay, so just we will start with the procedure now. We will say that when only 15 ampere source acts alone. Okay, so we consider now that only that first source, left source, is acting in the circuit. So again what we have to do now, we have to open circuit the current source, because see there is no voltage source now in this diagram, only two current sources are there, and since it is ideal current source, because they have not mentioned any internal resistance, we have to open circuit it. So we just open circuit this particular branch, so like this, okay. And then since we want to find out current in this 12 ohm resistor, For our own convenience, we will just mark these terminals as A and B because we need also the direction of the current. And now only this source is there. Now see, this source simply means that a 15 ampere current is sent to this node or 15 ampere current is taken from this node. Okay. So it will never be a part of our closed loop. Okay. We have seen that we can just replace it with the hanging wires like this. Even we can do it this way right now. So this is the only meaning of that current source. And now see your circuit, it will have two closed paths. One would be like this and the other one would be like this. Okay, so we may need two variables. So let us find out. Now see 15 ampere is coming like this. Suppose we assume that the current in this particular branch is say I1. So what current will go ahead here? 15 minus I1. Now this 15 minus I1 will reach to this node, to this point A. Some current will flow through this branch. So let us assume that in this 12 ohm resistor current I2 flows. So what current will go ahead here? 15 minus I1 minus I2. Now see, this current will reach here. There will be no flow of current in this branch because this is open now. So this entire current 15 minus I1 minus I2 will be flowing through this 9 ohm resistor. Now it comes like this. Again the same current will flow here because there won't be any current flow in this branch. And then at this particular node, the total current coming from this side is 15 minus I1 minus I2, and this I2 is added. So what will be the current moving towards left? It will be 15 minus I1. And now this 15 minus I1 reaches here, and this I1 is adding. So addition is 15, and see here the 15 ampere current is leaving the circuit. So this is our current distribution. Let us say that this is loop 1, or this we take as loop 2. And so we have to write the loop equations now. So for loop 1, what will be the equation for loop 1 now? See here, we start suppose like this. Our loop 1 is this to this, down, left, and again to the initial point. No component here. So now here from A to B, it will be minus 12 times I2. So minus 12 I2. Then we reach here towards left. No component here, and from this point to the initial point, it will be plus 18 I1. So plus 18 I1. This all will be equal to 0. So let us simplify it. It means that 12 I2 must be equal to 18 I1. Or we can say that I2 equal to 18 by 12. That is equal to 3 by 2 I1. So this we can say that this is our equation 1. And we write now equation for loop 2. What will be equation for loop 2 now? Our loop 2 is from this point here down towards left and again to the initial point A. Now this to this, no component here. Here there is a component. So it will be minus 9 into 15 minus I1 minus I2. So we reach here. Then towards left up to this point no component, and now this to this it will be plus 12 I2. So plus 12 I2. This will be equal to 0. Let us simplify. It will be minus 135, then plus 9 I1 plus 9 I2 plus 12 I2 equal to 0. So 9 I1, then 9 I2 and 12 I2. So plus 21 I2, and this 135 we take to other side. Okay. And now further we can simplify it. We can divide it by 3. So 3 I1 plus 7 I2 must be equal to 45. So this will be our equation 2. And now our job is to just solve this equation 1 and equation 2 and find out the values of variables. But in which value we are interested now? We want to find out current in this 12 ohm resistor. As per our current distribution, the current in the 12 ohm resistor is I2. So we are interested in finding out value of I2. So just solve these equations and tell me what will be the value of I2 and also the direction. Okay, so you can pause the video and solve the equations. So the answer for the I2 is 5 ampere and its direction is A to B. That means after solving the equations, we will find that you get a plus value for this I2. So I2 is plus 5 ampere. That means whatever direction we have assumed in our current distribution, that is correct, and our direction was from A to B. So we have written the first result as current flowing through 12 ohm resistor due to only first source, 15 ampere source acting alone. The current will be 5 ampere and it is flowing from A to B. So here again we write due to 15 ampere source. What is our result? The current in load resistor is 5 ampere and its direction is from A to B. In a similar manner, we have to do the procedure for the next current source. Now this will be the circuit that we will use for seeing the effect of only 10 ampere source. So we have written here when only 10 ampere source acts alone. And see here, we have open circuited the first source now, this 15 ampere source, and then we have shown this branch currents like this, okay, or see currents applied to these different nodes, okay. Okay, now let us have a current distribution. Now see here, again we will find that this is one smallest mesh and this is one more. That means we will again need here two variables. So somewhere we assume some current variable I1 and then I2. Suppose we assume that here the current is I1, okay. So 10 ampere is reaching to this node, I1 is going away. That means what will be with the current towards left? It will be 10 minus I1. Now this 10 minus I1 reaches here. Suppose we assume that current flowing here will be I2. So what will be current moving towards left? It will be 10 minus I1 minus I2. Now this entire current 10 minus I1 minus I2 will flow through this branch. See here, there will be no current towards left. Here it is an open circuit. So this will be 10 minus I1 minus I2. This entire current will flow like this. So this 10 minus I1 minus I2 reaches here. This I2 will be added there. So current moving ahead here will be 10 minus I1. At this node, 10 minus I1 is reaching and this I1 is also coming like this. So this I1 will add and see 10 ampere is leaving the circuit. So our current distribution is proper now. So let us take this as this mesh as loop 1 and this mesh as loop 2 and we write the equations. So for loop 1, what will be the equation for loop 1? Suppose we start like this, no component here, then here downwards it will be plus 12 I2 because we are traveling clockwise and this current is opposite now. So plus 12 I2, here no component and here it will be minus 18 into 10 minus I1 minus I2. So and this all will be equal to 0. Let us simplify it. So 12 I2 minus 180, then it will be plus 18 I1 and plus 18 I2 equal to 0. So here 18 I1 and 18 I2 plus 12 I2 is 30 I2 and this 180 we take to other side, so 180 here. So further we can divide by common factor, say by 6, so it will be 3 I1 plus 5 I2 equal to 30. This will be our equation 1. And then for loop 2, what will be the equation for loop 2? Our loop 2 is like this down towards left and back. So no component, here it will be plus 9 I1. Then we reach here, again no component here and it will be minus 12 I2. So minus 12 I2 and this all will be equal to 0. So 9 I1 equal to 12 I2, or we can say that 3 I1 equal to 4 I2. This is our equation 2. So we have got these two equations, equation 1 and equation 2. Again, we solve the equations. We want to find out the current flowing through this 12 ohm resistor. And as per our distribution, the current in 12 ohm resistor is I2. So we are interested in finding out the value of I2. Again here you can pause the video and solve the equations and find the value of I2 and also its direction. So the answer for I2 I have written here. You will get, after solving these two equations, you will get a current of 10 by 3 ampere but a plus value or positive value for this I2. That means as per our distribution, we have shown the current from B to A and we are getting a plus answer. That means the current flowing through this 10 ohm resistor due to the 10 ampere battery will be from B to A and its value will be 10 by 3 ampere. So here second result we will write due to 10 ampere source. What is our answer? 10 by 3 ampere. But now the direction is from B to A. Now see here which value is bigger. This 5 ampere is a bigger value. That means finally the current will be flowing from A to B. But we can compile it like this. Hence, current in 12 ohm resistor from A to B will be, what will be that value? So A to B, this is already A to B, so 5, and this is B to A, so we take it as negative, so 10 by 3, and so it will be 5 by 3 ampere. And this answer we are getting plus, that means current is really flowing from A to B when both the sources will be acting. Now one more problem we will solve with the help of superposition theorem. See here problem is find the current in 4 ohm resistor. They have not mentioned any internal resistances of the batteries. That means all our sources are ideal one. Now see, this is some combination. One voltage source is there and two current sources are there. Again we start with our regular procedure of superposition theorem. Suppose first we consider this 5 ampere source. So when 5 ampere source acts alone. Okay, so we consider only the first source. Here, so we make the necessary changes now in our circuit. What we have to do? When we are considering only this source now, then we have to replace this voltage source with the help of short circuit because that is ideal source. So this is gone. And we have to open current source. So this is open now. Whereas this source is supplying 5 ampere current, so that we will show here. So 5 ampere is supplied here or 5 ampere is taken. And you may also just scratch this from your diagram. So this will be the circuit. Now see here, this 5 ampere current is supplied at this node and also it is taken from this node. You will find that there are only two resistances connected in parallel across these two nodes. This is one branch and this entire is the second branch. Suppose we assume that the current flowing in this resistor will be I, then with the help of our knowledge of current distribution in two parallel branches, we can find it out. So what will be the value of I? Value of I will be total current. What total current is supplied at this node? It will be 5 ampere. Then in bracket a fraction. Now see, we want to find out current in this 4. So this 2 ohm will be in the numerator and in denominator it will be 2 plus 4. So it is simply this calculation. And just solve it, it will be 10 by 6. Or you can say that it is 5 by 3 ampere. And see now what will be the direction of current? Obviously, since this current is supplied from this end, current will be flowing like this. We mark these points as A and B. That means the current of 5 by 3 ampere will flow through this 4 ohm resistor and its direction will be from A to B. So here we write the direction as A to B. So first result we have obtained. Here I will write due to 5 ampere source, our result is 5 by 3 ampere, but its direction would be from A to B. So first job is over. Now let us consider the other source. Suppose we consider this 6 volt battery acting alone. So we have to make the changes in the circuit. Now this will be the circuit that we will use for finding out the effect of this 6 volt source. Now see here, both the current sources we have now replaced with the open circuit as usual. And see, only this will be the closed loop. So this battery of 6 volt, then current will flow through this 2 ohm. It will flow like this. It will come to point B. It will flow through 4 ohm resistor and back. So it is a simple circuit having this 2 ohm and this 4 ohm which are connected across the battery. So path of current is just like this. Okay, and total resistance in this circuit will be 2 plus 4, 6 ohm, whereas total voltage acting in this closed path is 6 volt. So very simply we can calculate it, 6 volt divided by 6 ohm. So current will be 1 ampere. And see what will be the direction, because this battery will be obviously giving current in this direction. It will flow like this. It will flow in this branch in this particular manner. So current will be obviously from B to A. So what is the result of the second source? The result is that directly here I will write, due to 6 volt source, what will be the current? Current will be 1 ampere and its direction is now B to A. And so let us move to the third source. For that we will make necessary changes in the given circuit. Now the third source is remaining, that we are considering now. So I have made the necessary changes in the diagram. See here, 2 ampere current is being supplied like this, or it is taken from this. This current source we have replaced with open circuit, and this 6 volt battery we have replaced with short circuit. And see, we have written when 2 ampere source is acting alone now. Now again, if we look at the diagram, clearly we get one idea that, see here, across these two nodes, there are 2 parallel branches. One is the 2 ohm resistor towards left, because see, this is open circuit, no current will flow. In short, this 2 ampere current will be distributed in this branch as well as in this branch in certain proportion. Again, we can make use of our knowledge of distribution of current in 2 parallel branches. So out of 2 ampere, some current would be flowing through this 2 ohm resistor and some current will be flowing through this 4 ohm resistor. We are interested in finding out the current flowing through this 4 ohm resistor. Obviously, we will find that this current is being supplied like this. Okay. So suppose this current is I. What will be the current in this 4 ohm resistor now? The total current supplied is 2 ampere. In bracket, since we want to find out current in this branch, this we will take in the numerator. So 2 divided by 2 plus 4. So it will be this thing. So here 4 divided by 6. And so it will be 2 by 3 ampere. Again, see what direction we get? We get the direction from A to B. So this current will be from A to B. And so third result we write here, due to 2 ampere source, what will be the current? Current will be 2 by 3 ampere, but its direction will be from A to B. And now let us find out the final result. So final result, we can calculate it like this. So we write current in 4 ohm resistor. Now any one direction we assume first, suppose A to B. From A to B, it will be equal to, now A to B, this first value is already A to B, so 5 by 3. Then second value is B to A, so we have to take this as minus 1. And third value is again A to B, so plus 2 by 3. And this answer will be 5 minus 3 plus 2. So 5 plus 2, 7, 7 minus 3 is 4, so it will be 4 by 3 ampere. So this is the final answer, and since we are getting plus value, that means this direction must be true. So final answer is current of 4 by 3 ampere flows through this 4 ohm resistor when all the 3 sources are acting together, and the direction of current would be obviously from A to B. So that is the way of solving the problems with the help of superposition theorem. Now it is very much necessary to see all the 3 tutorials, because that will give you a good idea of solving various types of circuits with the help of various theorems and also Kirchhoff's laws. Thank you.